current is same. First point, IL is equal to I phase. So at the same time, I phase is equal to IL. Then if the current is same, it means voltage has the difference. That is VL is equal to root 3 into V phase. Then V phase is equal to VL by root 3. Same formula, same thing is applicable in that secondary side. So that is I phase is equal to IL, IL is equal to I phase. Voltage difference. This is the star and star connection. Anybody have the doubts? ఎక్కడ ఏ పాయింట్ అయినా డౌట్ అనిపిస్తే అడగండి. మిస్టర్ రూల్ నెంబర్ 8 ఇంద్రలోచన్. మిస్టర్ ఇంద్రలోచన్, ఈ 8-9 మంది ఉన్నప్పుడు కూడా పిలిచినప్పుడు పలకకపోతే ఏంద్ర? మిస్టర్ ఇంద్రలోచన్, నామకే వాస్తే లాగిన్ అవ్వకండి నాన్న. రూల్ నెంబర్ 62.
సార్.
అర్థమైందా నాన్న? స్టార్ స్టార్ కనెక్షన్.
ఎస్ సార్.
ఓకే. రుత్విక్,
Sir.
is this clear?
Yes, sir. Sir,
So
like
then,
you said, it is connected in the star, no, sir. The left side diagram. Like once you explain.
see, star connection is nothing but every winding has the two terminal, means two ends. See, this is R phase. I assume that it is R phase, right? It is Y phase, it is B phase, right? It is one side, it is second side. It is one side, second side, one side, second side. All the second ends is connected at one end. That is neutral point. Same thing happen here. The second end is connected, second end is connected, second end is connected. See, the second end is connected now. Then it is star connection. All the primary winding, second end is connected at common point. That is neutral point. Okay now? Rutvik, say yes or no. Say something. Still confusion? Still you have the confusion?
No, sir. Clear.
Is this clear? Yeah. Next one, delta delta connection. So here delta connection is nothing but here I am drawing the simple circuit delta connection. R Y B. Then every winding has that R winding, one end, second end. Y the one end, second end. B winding, one end, second end. Right? So this is delta. So now R phase second end. This is first one end. Here I am putting it. One end, second end. Y phase first end, second end. B phase first end, second end. B phase second end. See here, R phase second end is connected to the B phase first end. లేకపోతే వై RYB, R face second end. See, R face second end is connected Y face first end. Y face first end. Here it is connected. You got my point? Then Y face second end is connected B face first end. Then B face second end is connected R face first end. Then it is called delta. See, just observe. Once just observe the circuit. Just observe the circuit. One end is connected to the another end. R face second end is connected Y face first end. Y face second end is connected B face first end. B face second end is connected R face first end. So this is delta connection. Same thing happen in the primary side. Sorry, same thing happen in the secondary side also. A9. A9
Sir.
ఏమైనా ఎక్కుతుందా?
Yes, sir.
సార్ టార్క్ స్లిప్ క్యారెక్టరిస్టిక్స్ చెప్పండి సార్ ఒకసారి.
ఎక్కడున్నావు నాన్న? టార్క్
స్లిప్ క్యారెక్టరిస్టిక్స్.
ఫస్ట్ ఇక్కడ చెప్తుంది ఇది మధ్యలో వదిలేయమంటావా? ఫస్ట్ ఇది ఇక్కడ చెప్తుంది అర్థమవుతుందా?
అర్థమవుతుంది సార్.
ఓకే. ఆకాష్, రుత్విక్.
Sir.
Is this clear?
Yes, sir. Clear.
Okay. So delta అర్థమైపోయింది అనుకోండి. So here in delta we know that in delta voltage is same. In delta voltage is same. So VL is equal to V face, then V face is equal to VL. Then if the voltage is same, it means current has the difference. Current has the difference. What is the difference? Right? √3 times. The difference, it should be √3 times difference. Right? Is already చెప్పాను. So line current is always greater than the √3 times of the phase current. IL is equal to √3 into I phase, and I phase is equal to IL by √3. This is the delta connection. Same thing, secondary side is also same thing happens. Then third one is that yeah, after delta, yeah, third one is the star delta. So what is that? Primary side star, secondary side delta, right? Is this difficult? Once we know that the star and delta, then star and delta, it is very easy. Okay na? ఏమా సినా సారా ఉన్నారు. ఓకే, నెక్స్ట్ ఏమన్నారు? టార్క్ స్లిప్ క్యారెక్టరిస్టిక్సా? ఇక్కడ మీకు 4th యూనిట్లో కొన్ని ప్రాబ్లమ్స్ ఉంటాయి, సింపుల్ ప్రాబ్లమ్స్, అసలు వెరీ డెడ్ ఈజీ ప్రాబ్లమ్స్. స్లిప్ ఫ్రీక్వెన్సీ అవి ఫైండ్ అవుట్ చేయమని చెప్తారు. యా, so here the problem is a 3-phase 6-pole 3-phase 650 Hz squirrel cage induction motor is running with a slip of 4%. With a slip of 4%, determine the speed of rotating magnetic field అయితే మీ దగ్గర ఈ స్లిప్ రొటేటింగ్ మ్యాగ్నెటిక్ ఫ్లక్స్ మీద దెన్ సింక్రనస్ స్పీడ్ మీద ఏమైనా ప్రాబ్లమ్స్ ఉంటే ఇవ్వండి. మీ దగ్గర కూడా రొటేటింగ్ మ్యాగ్నెటిక్ ఫీల్డ్ రిలేటివ్ టు ద డిటర్మైన్ ద రొటేట్ అయిపోయిందా? ఓకే, చలో.
వీడియోలో ప్రాజెక్ట్ చేస్తున్నాం సార్, సో దానికోసం లెటర్.
ఓకే, ఆల్ ది బెస్ట్. ఎవరెవరు?
నేను ఒకదాన్ని
సింగిలా?
అంటే ఇప్పుడు డాడీ ఎంప్లాయీస్ సార్, దాంట్లో సో ఓన్లీ ఎంప్లాయీస్నే వాళ్ళ కూతుర్నే తీసుకుంటా అన్నారు.
ఎవరైనా జాయిన్ మరి బ్యాచ్గా ఇంకొన్ని పెట్టుకోకపోయినా?
అడిగినా సార్, అంత దూరం మేము రామంటున్నారు.
అవునా?
మా ఇల్లు అయితే పక్కనే సార్.
ఇంత మంచి ఆపర్చునిటీకి రామంటున్నారు. ఇన్ఆర్బిట్ లో మంచి షాపింగ్ కొత్త వచ్చినాయంట, మూవీ చూద్దామంటే వస్తారా హ్యాపీగా?
అంటే షావికని అడిగినా సార్, కానీ కొంచెం ఎమర్జెన్సీ ఉంది, ఊరికి వెళ్తుంది. ఇక మిగతా వాళ్ళు మా గ్యాంగ్ లో ఇంట్రెస్ట్ ఉండదు. చాలా దూరం మీ ఇల్లు, మేము రామంటున్నాడు. థ్యాంక్ యూ సార్.
ఓకే, యా. ఇక్కడ ఫస్ట్ ఆఫ్ ఆల్ మీకు కొన్ని ఫార్ములాస్ ప్రాబ్లం కంటే ముందు, we have the slip is equal to that is ns minus n by ns. గుర్తుదేమన్నా ఎవరికన్నా? percentage slip is means by 100. Here ns is the synchronous speed, n is the rotor speed, ns is equal to again ns is equal to 120 into f by p. Here f is the supply frequency, p is the number of poles. P is the number of poles. These are the formulas are very important. Ns minus n by ns into 100. That is ns is equal to 120 F by P. Then మీకు ఇవి FR is equal to అంటే rotor frequency under running condition. FR is equal to rotor frequency under running condition S into F. What is S here? S means slip. How to calculate S here? Ns minus n by ns. ఈ ప్రాబ్లమ్స్ ఈ ఫార్ములాస్ బేస్ చేసుకొని ప్రాబ్లమ్స్ ఉంటాయి కొన్ని. అవి చూడండి, ఏమైనా ప్రీవియస్ క్వశ్చన్ పేపర్స్లో కానీ ఎక్కడన్నా అర్థం కాకపోయి ఉంటే అవి చూడండి. మీకు బైండింగ్ మీకు జిరాక్స్ స్పైరల్ బైండింగ్ ఇచ్చాం కదా, ఉందా అది అందరి దగ్గర?
Yes, sir.
అశ్రిత, నెంబర్ 85 అశ్రిత
సార్
ఉందా జిరాక్స్?
ఉంది సార్.
షూర్?
ఎస్ సార్.
చూపించు ఒకసారి.
ఓకే.
పరీక్షిత్
సార్
ఉందా జిరాక్స్?
ఉంది సార్.
ఓకే. పరీక్షిత్ షో మీ దట్.
సార్
ఓకే అమ్మా అశ్రిత, ఓకే చూపించినాను ఒకసారి నాకు నీ బుక్.
ఎస్ సార్.
చూపించు అనగానే ఒకటి జంపు. బట్ నేను ఇచ్చినప్పుడు ఎంత ఫ్రెష్గా ఉందో ఇప్పుడు అంతే ఫ్రెష్గా ఉంది. ఏంద్రా
అంటే ఇంకేం చదవలేదు సార్, చదవాలి.
అసలు ఓపెన్ చేసినట్టు కూడా లేదు కదా. ఇప్పుడే ప్రింటింగ్ నుంచి ఫ్రెష్గా తెచ్చినట్టుంది. చదువునాను మరి. నేను డౌట్స్ అడగండి. ఏం డౌట్స్ లేవా? అసలు మీరు చదవడం కరెక్ట్ స్టార్ట్ చేస్తే డౌట్స్ వస్తాయి. సార్ చెప్పండి. ఓకే, టోటల్ 3 సెక్షన్స్లో ఓకే ప్రజెంట్ చెప్పాలా ఆబ్సెంట్ చెప్పాలా? ఓకే. Go.
Sir,
What else?
sir, like derivations are there, no, sir? Like RMS of alternating sinusoidal waveform of, and like another derivations also there, no, sir? Like torque equations.
Yeah, we derived that, na? Torque
Yes,
equation.
sir. Like are they important, sir? We need to prepare right
Yes,
now.
yes, yes, yes.
COVID
Torque
pattern, sir.
equation is very important.
Okay, sir. Like any other important, sir? Any other important derivations, sir?
Just learn the EMF equations. Those we have the 3 EMF equations. That is EMF equation of single phase transformer. We derived that equation. What is that EMF equation of single phase transformer? That is, if it is primary, E1 is equal to 4.44 into F into, that is IM అన్న రాసుకోవచ్చు, or otherwise BM into A.
BM into E.
BM into A. If it is E1, then here it is N1. If it is secondary side, that is E2 is equal to 4.44 into F into, that is BM into A into N2 volts. These are the EMF equation of primary as well as secondary, right? So 4.44 F BM A, these are all common in that both. So here I am writing directly E1 is directly proportional to N1 and E2 is directly proportional to N2. So at the same time here transformation ratio K is equal to number of secondary turns to the number of primaries. So N2 is directly proportional to E2 kada. So at the same time K is equal to, I am writing E2 by E1. So in practical transformer E2 is, E2 directly proportional is approximately equal to the not directly proportional V1. So at the same time here I am writing V2 by V1. When it comes to the current, it must be I1 by I2. This is one EMF equation of transformer. Then we have the another EMF equation in the generator. EMF equation in DC generator. What is that? Induced EMF EG is equal to, we derived that equation, pi Zn by 60 into P by A. What is pi here? Flux per pole in Webers. What is Z here? Total number of armature conductors. What is N here? Speed of the armature in RPM. What is P here? Number of poles. What is A here? Number of parallel paths. In lap winding, A is equal to P for lap winding, and A is equal to P for lap winding, and A is equal to 2 for wave winding. This is the EMF equation of DC generator, right? Then we have the back EMF or counter EMF equation in motor. We call it is back EMF or counter EMF of DC motor. So that is we denoted with EB. EB is also same like as pi Zn by 60 into P by A. And when it is the physical part, this is a physical part. If it is according to voltage or those equation, EB is equal to V minus IA RA. These are the then next EMF equation of alternator. In alternator also we have the EMF equation. EMF equation of alternator. ఇది మీకు ఎంతగా అడగకపోవచ్చు ఆల్టర్నేటర్ EMF equation. Just leave that EMF equation. So these are the and torque equation in a DC motor. Torque equation of a DC motor. That is, we derived that T is equal to 0.159 into pi into Z into IA into P by A. Here pi is the flux per pole, Z is the total number of armature conductors, IA is the armature current, P is the number of poles, A is the number of parallel paths. ఇంకేమైనా డౌట్స్?
Sir, any other important derivations, sir?
ఇంకా మనకు డెరివేషన్స్ ఇంకా ఎక్కడ వచ్చాయి? టార్క్ ఈక్వేషన్ ఆఫ్ 3-phase ఇండక్షన్ మోటార్ మార్నింగ్ చెప్పాను కదా, దట్ ఈస్ T ఈజ్ ఈక్వల్ టు సమ్ కాన్స్టెంట్. ద కాన్స్టెంట్ అది కూడా కంక్లూడ్ చేద్దాం. సో హియర్ టార్క్ ఈక్వేషన్ ఆఫ్ ఇండక్షన్ మోటార్. Equation of a 3-phase induction motor. Torque equation of a 3-phase induction motor. From this equation, once the motor is designed, 0.159 Z P A, these are the all constant. Then torque is directly proportional to flux and armature current. So here also directly flux and armature current. Right? Here flux is directly proportional to EB, or EB means in that armature, here we call it is E2. So from that we are deriving that equation, torque is equal to some constant S into E2 square by R2 square plus S into X2 whole square into R2. Here K is also some constant, that is 3 by 2 pi ns, small ns. What is ns? Synchronous speed. These are the derivations. Here it is R2. These are the main equations in that. ఇంకేమున్నాయి మనకు డెరివేషన్స్? These are the equations. దువ్వురి.
ఎస్ సార్.
చదువుతున్నావా తల్లి?
ఎస్ సార్.
పాస్ అవుతారా బీడబ్ల్యూ అందరూ? పోస్ట్ పోన్ అవ్వకుండా ఆ ఫ్లోలో ఎగ్జామ్ అయిపోతే అయిపోతుండే కదా అప్పుడు. టైం వేస్ట్ వద్దు, ఏమైనా డౌట్స్ ఉంటే అడగండి. టైం వేస్ట్ వద్దు, ఏమైనా డౌట్స్ ఉంటే అడగండి, వెరిఫై చేయండి. యూ కెన్ లీవ్, నేను 4 వరకు ఉంటాను. యూ కెన్ లీవ్, చదవండి, ఏమైనా డౌట్స్ ఉంటే మళ్ళీ రండి. ఊరికే ఇక్కడ ఉండి టైం వేస్ట్ ఎందుకు. ఇది డౌట్స్ క్లారిఫికేషన్ కోసమే పెట్టాను.
Like only this torque equation of three-phase induction motor and before one, like only these are like most important, sir.
So that EMI, here I am talking about the derivations. So derivations in the complete all units. In the second unit we have the some derivations. What is that? AC pure resistor, pure inductor, pure capacitor. We have the derivations. How those current and voltage relation ఎలా వచ్చాయో మనం క్లాస్లో చేసాం చాలా పర్ఫెక్ట్గా. AC through pure resistor, if the voltage as the reference vector తీసుకుంటే మనకు కరెంట్ ఎలా వచ్చిందన్నది అక్కడ డెరివేషన్ చేశాము. I will show you those, if possible I will show you. Here RMS, how to calculate the RMS value also. Here we have the derivations. RMS value, average value also we have the derivations. Yeah, this is also derivation. AC through pure resistor. Are you able to see this topic, AC through pure resistor?
Yes, sir.
So that is here derivation. So in the second unit, E is equal to EM sin omega t. Here I am considering one resistor. Then I is equal to E by R. Then I is equal to EM sin omega t by R. Means current is equal to voltage by resistor. That is the standard law. Then IM is equal to EM by R. So EM by R sin omega t. EM by R is nothing but IM. So we got that here I value. So it means equation 1 and equation 2 compare cheste, right? Both are same. So it means voltage and current are in phase to each other. The phase angle between the voltage and current is 0 degrees. Then power factor cos pi is equal to 1, right? Then here power equation, power E into I, EM sin omega t, IM sin omega t, IM common is the sin square omega t. Then sin square omega t we can write down 1 minus cos 2 omega t by 2. Then here real part and imaginary part, if you are separated, EM IM by root 2 and EM IM my cos 2 omega t by 2. So here average value is 0. Then EM IM, these are the one derivation. This is AC through pure resistor. Then AC through pure resistor, after that AC through pure inductor. See this. So AC through pure inductor. Here I am given supply voltage E is equal to Em sin omega t. Then inductor, the voltage drop across that inductor is EL, right? Then EL is equal to how much voltage drop across that inductor? That is L into di by dt. Then according to that Kirchhoff's laws, algebraic sum of applied voltage, that is equal to the drop voltage. So that's why E is equal to EL. E is equal to EL. Then E is equal to, yeah, EL is equal to what is that? L into di by dt, right? Then, so here just E is equal to Em sin omega t. Then here, yeah. So first ikkada E is equal to L into di by dt. Then నేను L ని ఇటు పంపించాను. di is equal to రాసుకున్నాను. di is equal to E by L dt. Then I is equal to integration of both side. Integral చేస్తే E by L dt. So E is equal to here Em sin omega t, right? Then I is equal to Em by L sin omega t. Integral of sin omega t dt, that is minus cos omega t by omega, right? Then minus common తీస్తే minus Em by omega L cos omega t. Cos omega t ని నేను ఎలా రాసుకున్నాను? sin pi by 2 minus omega t. Then ఇక్కడ minus common తీస్తే sin omega t minus pi by 2, right? So that is again that equation E by omega L. Omega is equal to, we know that it is 2 pi half L sin omega t minus pi by 2. So here Em by omega L, that is nothing but XL, right? Em by XL, that is Im. Then Im equation we got here sin omega t minus pi by 2. So it is the lagging. So this is also one derivation. You got my point? ఇవన్నీ మనం చేశాం. రుత్విక్.
Yes, sir, got it.
Oh. Mr. Nitin Reddy. Mr. Nitin Reddy. Mr. Nitin Reddy, rule number 50. ఇంకేమైనా డౌట్సా? ఓకే నాన్న, ఇక చదువుకోండి మరి. ఇక డౌట్స్ లేకపోతే అశ్రిత ఏదో పంపినట్టున్నా. ఏంటమ్మా ఇందులో?
4A సార్, రెజొనెన్స్ సమ్ ఒకటి.
4Aనా? నాకు వాట్సాప్ పంపమ్మా అది. నాకు వాట్సాప్ చేయాలి. Yeah.
Jason, sir.
Yes. So here a coil having an inductance of L is equal to 2 Henries in series with a resistor of R is equal to 10 ohms and capacitor C is equal to 50 microfarads. The whole combination is connected to a supply voltage V is equal to 200 volts. Variable frequency supply. First ఏం ఫైండ్ అవుట్ చేయమన్నారంటే resonant frequency. Required data. First one is resonant frequency. Resonant frequency FR is equal to, that is 1 by 2 pi under root of LC. మనం డిరైవ్ చేశాం ఇది. ఎలా వస్తుంది మనకు అంటే XL is equal to XC. XL is equal to what is that? 2 pi FL, that is equal to the 1 by 2 pi FC. Right? These are the F naught, 2 pi FL. దీని నుంచి మనకి ఈక్వేషన్ ఇది వస్తుంది. FR, ఇది FR అనుకుంటే ఇది కూడా FR అనుకుంటే దీని నుంచి మనకి ఈక్వేషన్ వస్తుంది. 1 by R is equal to 1 by 2 pi under root of LC. Right? So FR is equal to 1 by 2 pi. Then calculated 1 by 2 into pi into under root of L is equal to 2. C is equal to 50 into 10 to the power minus 6. Calculate చేయమా. First under root of 2 into 50 into 10 to the power minus 6 into 2 into 5.
15.9.
1 divided by answer. 15.923 Hz. First bit is done. Second bit. Second bit ఏం అడిగారు? Resonant frequency. The current in the circuit at resonance. So at resonance, XL is equal to XC. Then Z is equal to, what is that formula? Under root of Z standard formula idi R square plus XL minus XC whole square. Then this term will be 0 at resonance. This term will be 0. Then Z is equal to R. Okay. Then what is the Z value now? R is equal to how much here? R is equal to 10. Then Z is equal also 10. Then current I is equal to V by Z. Then V is equal to how much here? Sub voltage 200 by 10. How much it is current? 20 amps. Simple. ఇక్కడ మీరు క్యాచ్ చేయాల్సిన one point, at resonance XL is equal to XC. Then this term will be 0. So when this term will be 0, Z is equal to R. right? In place of Z, so current I is equal to V by Z, then Z is equal to R is equal to 10, then 200 by 10. How much it is? 20. Yeah. Next, third bit. Third bit unna. The current in the circuit at resonance అయిపోయింది, then current corresponding voltage developed across the capacitor. So third bit is we have to calculate the corresponding voltage drop across the capacitor. Voltage drop across the capacitor, that is VC is equal to, that is I into XC. So XC we have to calculate. What is XC? XC
1 by 2
is
pi
equal
FC.
to 1 by 2 pi FC. That is 1 by 2 into pi into F is equal to how much? 50. C is equal to 50 into 10 to the power minus 6. Calculate it. ఎంత వస్తుంది?
66.63, sir.
66.63 ohms. Then go to calculate next I. I is equal to V by Z here. This is third bit is not at resonance, right? It is general circuit. So Z ikkada V by Z. Z is equal to what is that here? Again we have to calculate Z value. Here Z is equal to not R. Guys, please try to catch my point here. Here Z is equal to not R. So we have to calculate Z. Z is equal to what is that? Under root of R square plus XL minus XC whole square. R తెలుసు, XC ఇప్పుడు calculate చేశాం. Then calculate the here XL. XL is equal to 2 pi FL. That is 2 into pi into F is equal to how much? 50 into L is equal to how much? L is equal to 2 Henries. 2 Henries కదా ఇచ్చింది.
Yes, sir. 2.
Yeah. Calculate XL. 445, 450, 200. Calculate it.
$628, sir. XL.
620.
628.3.
628, sir.
Okay. Then Z is equal to under root of R is equal to how much here? 10 square plus XL. XL is 628.3 minus XC 66.63 whole square. Calculate the Z value. Calculate the Z value.
Sir, 561.79.
561.79. So once we know that the Z value, then we can calculate the I value. I is equal to how much? V by Z. That is 200 by 561.79. Calculate it.
$0.351.
0.351 amps. So once we know that the I, then next I is equal to how much? 0.351 and XC 66.63. That is the voltage across the capacitor.
సార్ ఆ పేపర్లోనే 5B కూడా ఒకసారి చెప్పండి సార్.
5B ఒక్క నిమిషం అమ్మ. 5B చెప్పే ముందు గజవాడ ఆస్కింగ్ సంథింగ్ 8B. నువ్వు yeah, that is 8B. గజవాడ 8B కదా?
Yes, sir.
ఇక్కడ కూడా పెట్టు. ఇది మళ్ళీ నేను ఎక్స్ప్లెయిన్ చేస్తున్నా. మొత్తం ప్రాబ్లం రాయను, డైరెక్ట్ డేటా రాసిస్తాను. 8B ఐఎమ్ రైటింగ్. That is which is the Gajawada Sriya question paper. That is 10 pole, P is equal to 10. Then 3-phase induction motor runs at a speed of N is equal to 485 RPM at F is equal to 50 hertz. 50 hertz supply. Determine synchronous speed and slip. చూడండి ఎంత సింపుల్ ప్రాబ్లమ్. These are the given data. What is the required data? What we have to calculate? What is the required data? What we have to calculate? Synchronous speed. That is first bit is ns and second bit is s. So ns is equal to what is the formula?
120 into F.
120 into F by P. That is 120 into F is equal to how much? 50 by P is equal to 10. Calculate it. 120 into 5. How much?
600.
600, sir.
600 RPM. Right? This is first bit. Then second bit, what we have to calculate? Slip. S is equal to what is that? Ns minus N by Ns. Percentage slip anukunte multiply with 100. Ns is equal to how much here? 600. N is equal to 485 by how much? 600 into 100. Calculate it.
.191, sir.
Multiply with 100.
Sir,
191.
19.16.
10.1.
19.16, sir.
19.16.
sir.
16. Simple problem. See,
సార్
గజవాడ నీ పేపర్ కూడా పెట్టమ్మా ఇక్కడ చాట్ బాక్స్ లో. ఎస్.
సార్
ఆ,
in AC circuits, we used I is equal to V by Z, no sir, in place of
Yes.
resistor impedance.
yes, yeah, exactly.
Sir, like what is impedance, sir? Like, how can we think of that? Like, how to define?
What is impedance? See, the only thing is, in DC circuit, the frequency is not considerable thing. We don't have the frequency. Here, reactance terms is not there in the DC. So that's why in DC, that is current I is equal to V by R. But whereas it comes to the in AC, here I is equal to V by Z, because of here frequency is considering, right? So when the frequency is considering, so the inductive reactance as well as capacitive reactance are affected. So here frequency is not there. So XL and XC is 0. That's why it is V by R. Okay.
Yes, sir. Sir, like we can relate R and Z, sir.
How can relate?
Like, like in DC, for normal resistor, like we use resistor.
Generally, do one thing. Z is equal to under root of R square plus XL minus XC. What is XL? 2 pi FL, right? If the frequency is 0, what is this value?
R, sir. Z equal to R.
What is the XL value? 0. XC also 0. So that's why Z is equal to R. If the frequency is not considering, here if the frequency is 0, here F is equal to 0. So that's why V by, it is not considering. You got the point?
Yes, sir. Sir, and another doubt, sir. Sir, like in second unit we use like reactance, no sir, XL inductor reactance and capacitor reactance.
Where?
Sir, like what does that mean, sir? Reactance means what?
Here reactance and admittance are both are same.
No, admittance is the reciprocal of the impedance.
Okay.
In place of reactance, we have the susceptance. Admittance is the 1 by Z. Admittance we denoted with Y. Admittance we denoted with Y, and it is equal to 1 by Z. Okay. Okay, today we will end the session.
Sir, like reactance definition, sir.
Reactance is also exactly definitions ante meeku it is affected in that imaginary axis. షార్ట్ టర్మ్ లో చెప్పాలంటే ఇట్ ఈస్ లెంతీ నాన్న. మీకు ఇప్పుడు అసలు వై యాక్సిస్ లో ఆ జే టర్మ్స్ ఏంటి, ఎందుకు వస్తుంది, అదంతా పెద్ద సోది. ఇట్ ఈస్ జస్ట్ అంతవరకే గుర్తుపెట్టుకున్నాను నేను, ఇంకా లోతుకి వెళ్ళకు. ఇట్ ఈస్
Yes, sir.
బెటర్.
It is affected in the imaginary axis and it is created, sir.
Today we will end the session now.
Thank you.
ఏం చేస్తారు ఇప్పుడు, నిద్రపోతారా?